In this lesson, we'll be factoring using the distributive property. By the end of the lesson, you should be able to factor polynomials using the distributive property. So inverse operations, add and subtract are inverse, multiplication and division are inverse, squared and square root are inverse, and distributing and factoring are inverse. So how do we know when it's in simplest form? It needs to be completely factored, meaning the GCF is 1. So it's relatively prime. So on this one, 2a times 2a plus 4, 2a and 4 does not have a GCF of 1. That GCF is 2. So we need to factor out another 2. When you're factoring a polynomial, find the GCF of the coefficients, then find the GCF of each variable, and just make sure that you recognize that y minus 7 and 7 minus y are not exactly the same. But if I factor out a -1, that gets that to be plus and this to be minus, and then they are the same. Factor by grouping means that I have a polynomial with 4 or more terms. So terms with common factors are grouped together. There's multiple ways usually that you can group them. We need to change it to the form so we have a number, and then notice this is c plus d, a different number, but this is c plus d. These two have to match exactly. When we're done, you could FOIL to check them. When you do get it factored, these two that match exactly are one term, and then this one and this one go together to make that term. So some examples. So first I look at the numbers and find the GCF of 12 and 16, and that is of course 4. And then I have a squared and an a, so the GCF is a. Then I divide this by 4a and this by 4a. 12a squared divided by 4a is 3a, because when you divide you subtract. And then 16 divided by 4 is 4, and then a over a cancels out. That's my answer. To check, just do 4a times 3a, that's 12a squared, and 4a times 4a is times 4 is 16a. All right, GCF of the numbers, 18, 12, and 9. GCF of that is 3. I've got it 1c, 2c is 1c. GCF is 1c. 2d's, 1d, 1d. GCF is d. Divide this by 3cd, and that gets me 6d. This by 3cd, that gets me 4c. And this by 3cd, that gets me 3. If you want to check, just distribute all the way across. All right, factor by grouping. So I'm going to group these two, but I could just as easily move that 3a over next to the 4ab and group it that way. I'll get the exact same answer. So looking at these two numbers, my GCF is 4. Only one a, but I got a b in both. So I'm going to divide them by 4b. And that gets me a, 4b, sorry, plus 2. Over here, factor out a 3, and that gets me a plus 2. Remember, these two have got to be exactly the same. Now I put these two together, 4b plus 3 times a plus 2. FOIL to check. All right, factor by grouping. I'm just going to use these two and these two. So over here, my GCF of 35 and 5 is 5. 1x, no y's in the second one. So divide this by 5x, and that gets me 7. Divide this by 5, and I get 5x. I get minus y. Over here, I'm going to divide these both by 3, so that gets me y minus 7. These two are not exactly the same. But if I go back and I divide this by -3, then that would be negative y and positive 7, which is 7 minus y. Now, put those two together, 5x minus 3 times 7 minus y. FOIL to check. Coach Jones is scheduling a league baseball games, and to find the number of games he needs, he can use this equation, G equals 1/2 n squared minus 1/2 n. Write the equation in factored form. So the GCF I have here of the numbers is 1/2, and then I got an n squared and an n. So that means GCF of n. If I divide 1/2 n squared by 1/2 n, that leaves me an n. And 1/2 n divided by 1/2 n is 1. So that's my equation. Then it says for 5 teams. Remember, n was the teams. So 1/2 times 5 times 5 minus 4. 1/2 times 5 is 2.5, sorry, times, oh my goodness, this is 1. I don't know why I put that, I was working ahead. Times 4. 2.5 times 4 is 10. So they need to play 10 games to play each other, but they want to play each other 4 times. So 10 times 4 is 40 games. Is there more than one way to group polynomials when factoring? Yes, definitely. There's probably multiple ways. How can you check your answers after you factor? By either just doing distributive property or foiling.